This video is for section 1.8. This is part 2, and the notes have to do with using a normal model. So here we're going to discuss what is a normal model and something called the 68, 95, 99.7 rule, and it is also known as the empirical rule. So here we have the title. It is using a normal model. For a normal model, our first bullet point says by standardizing values, we shift the distribution so that the mean is 0 and rescaling it so that the standard deviation is 1. The normal model is symmetric and unimodal, like here. So we're talking about like a bell-shaped curve, a smooth curve like this. Because it is a model, we use sigma. So we use this Greek letter sigma and this Greek letter called mu. It does not come from the actual data. So sigma and so the sigma and the mu are the parameters that specify the model. The z calculations. So we're going to learn how to do z calculations for a normal model. Z is equal to x minus the mean. So the mu, we're gonna represent mean with the letter mu, with the notation here, divided by the standard deviation. Okay, and then for the 68, 95, 99.7 rule, it follows the following. It tells us that 68% of the values fall within one standard deviation from the mean. 95% of the values fall within two standard deviations from the mean, and about 99.7, almost 100%, of the values fall within three standard deviations from the mean. We are now going to look at a picture that will help clarify the concept of the empirical rule. Here we see a basic model of this illustration of the empirical rule. I'm going to go over some slides here that tell us more about the empirical rule. So you see here, you draw a bell curve shape with the mean in the middle, and then you go from the middle, you go left and right, one standard deviation away. So to the right of the mean is positive, and to the left of the mean is negative. And then you go further out, you get two standard deviations, and at the very ends, at the tails, you have three standard deviations away. Okay, and from this other version of the normal distribution, we see that the bell shape is symmetric. Within one standard deviation, you have 68% of the values. 95% are within two standard deviations, and within three standard deviations is 99.7. And the total area under the curve is 1 or 100%. Here you have the notation. This capital N tells you that you're looking at a normal distribution, parentheses, the mean, and then the standard deviation. It is good to know the standard deviation because we can't say that any value is likely to be within one standard deviation, very likely to be within two standard deviations, and almost certainly within three standard deviations. Here's another version of the empirical rule. This illustration tells you the 68, 68, 95, 99.7. Since you know that this is a symmetric curve, you could go further and analyze these percentages even more. For example, this, actually, let me put it right here. Here you see that this aqua blue color here is 68% of the values, but if you divide that into two parts, you get 34 and 34. So you get 34% on each side. And then the yellow part, so from yellow to yellow, that contains 95%. But if you subtract 95 minus 68 and then divide it by 2, then you'll get the 13.5 and 13.5. Same thing for the red part. These little red tails here are 2.35%, and you could get that by simply subtracting 99.7 minus 95 and then divided by 2. And then at the very end, you have this green color where only 0.15% of the values lie at the very end, at the tails. So here, back to the guided notes. You can take a picture of this, or if you have the tools, try to sketch out a normal bell curved shape like this and label the parts. And look at the color coding, right? So this is 68% for the blue, 95% for the green, and all the gray is 99.7. And look at this notation, n comma 0, 1 is the mean is 0 and 1 is the standard deviation. Here is an example that has 3 questions. You could pause the video here and try to answer this this question on the normal model. All right, and then I will use a separate page to work out this problem here. It says a normal model describes the fuel efficiency of cars currently registered in Nevada. The mean is 24 miles per hour. Fuel efficiency, so this is miles per gallon with a standard deviation of 6 miles per gallon. The first thing that we do here is we're going to draw our curve. So here I have a little template, and then I'm going to go and write some things in it and label my graph here appropriately. So let's see, drawing. So we have the mean of 24, so we put that in the middle, and then the standard deviations are 6. So from here to here, you add 6. So you add 1 standard deviation. You add 6, which is 1 standard deviation. So this is going to be 30. And you add 6 again, 36, and then 42. You do it 3 times for 3 standard deviations. And then you could go the other way. You could go backwards. So you take away 6 for 1 standard deviation away from the mean. So that's going to be 18, then 12, and then 6. Okay, so that's how I label my axis here. Now this says question number 1, what percentage of the cars will get more than 30 miles per hour? So I'm looking at the visual here. 30 miles per hour looks like it's from here to all the way over here. Okay, so from here to here. If I use my, let me erase this. I'm gonna use the bottom of my page here to visualize the percentages here. So 30 miles per gallon is one standard deviation and above. So you're gonna be adding, let me see. So 30 miles per gallon will be here. So you want to add the 13.5, 2.35, and 0.15. Okay, so if you do that, let's do it right here. So right here, add 13.5 plus 2.35 plus 0.15 is equal to 16%. You change that to a percentage at the end. Okay, the next one, it says what percentage of the cars will get between 12 and 18 mpg. So let's see, 12 to 18 is right here. So 12 to 18 is only talking about this little piece here. Right, so this little section. So you have the middle right here. You have from one standard deviation to the second standard deviation. So we want that percentage. And if we look at our empirical rule, so that is 13.5, which is right here. Okay. So here it's only 13.5%. Okay, what percentage of the cars will get less than 12 mpg? Less than 12. So let's see. Oops. Okay. Okay, so less than 12 is from the second standard deviation and below. So it's going to be, where is it? Here we go. So we're going to get these values here. Okay, so you're going to add 2.35 and 0.15. So let's add 2.35 plus 0.15, and then we should get about 2.5%. Okay, so that's how you do that example. All right, and if we continue with our notes here, we are done with the example. Now it says, before using a normal model, you want to verify. We are right here in this section. Verify that your data meets the nearly model conditions. So examine the shape of the histograms, stem and leaf plots. Check that if it's symmetric about the mean and bell-shaped. Compare the mean and the median. In a normal model, the mean and median are equal. Okay, so in here, in right in the middle, you'll have the mean and the median. On an AP exam, right, that you check these conditions, check for the normality conditions, and then you would use this notation. This capital N lets you know that you're working with a normal model. Okay, and then we have an example that has to do with this SAT math test. Try to do that example on your own, and then we work it out and show you the solution. And I will go ahead and do this example here. So the question, first it says when a z-score isn't exactly 1, 2, or 3, like the example with the gas, with the fuel efficiency, then we need to use a z-table or a normal CDF on your calculator. The question says the normal model for SAT math test is 500 and 100. So this notation, you know that the first number is the mean and the second number is the standard deviation. What percentage of the students scored below 450? So first I'm going to label my standard deviations and label my picture, right? So the mean is 500 with a standard deviation of 100. So that means that this would be 600, 400, 700, 800, and so on. Okay, I need to identify below 450. So the first thing that we're doing here is you got to draw a picture. First, draw a picture. So draw a curve and label the 450. So 450 would be right here. And I want to know the percentage of scores from here all the way up to here. Okay, so that's why the empirical rule won't help us too much here, but it gives us an idea that, hey, maybe the answer has to be less than 50% because it's below the mean, right? Okay, so one way to do that is by use this. We will need to proceed and use the z-score formula. So the z-score formula that we're going to use is equal to the individual value, like the 450, minus the mean divided by the standard deviation. So if I standardize this score and I plug in the values, I will get 450 minus 500 divided by 100. And that should result in negative 0.5. So I've done two very important steps right now. I've drawn the picture and I found a z-score. Now from here, you could go to the calculator or proceed with a table, a table, um, a z-table. It's important to know both. So the way you read it in a z-table, there's another video for that. But if you look at this table, which is found here, it has a lot of values here, but what you're looking for is for negative 0.5. So negative 0.5, if I'm looking on the right, on the margins is where you see the z-scores. So negative 0.5 is right here, and it goes with 0.3085. So the percentage from the table gave me probability that X, or the percentage that X is below 450 is 0.30. Wait, I ran out of space here. Let me do it over here. Okay, so this is about maybe 30.85%. and it confirms that this is definitely less than 50%, so it makes sense. Now, a little bit about the calculator. If you use the command, let's see, norm CDF or normal CDF, you need four numbers in there. You need a low bound, a high bound, the mean, and the standard deviation. Um, a little bit bigger. Okay, so you need the calculator command is norm CDF and put in four values. The values that we would use for this example. Look at the picture. The picture says for our lower bound, you want to use a very small number, so very out here to the left. So we usually put negative infinity. You need the infinity symbol. I don't have it here, but it'll be negative infinity. I'll just type in the word infinity. And it goes all the way to 450. The mean is 500 and the standard deviation is 100. If you put that in your calculator, it should give you something very close to 0.3085. Example number 2, what percentage of students score above 620? So I got to label my picture and kind of estimate where, so I could get an idea where 620 is at. So I want above 620. First thing I'm doing is I got to label 620. So 620, maybe it's right here because 600 is here. So I want from here all the way over here. So that's a small amount. All right. So now the calculator command that will give you this, it'll be norm CDF. You need your low bound. This time is 620. And I want it all the way over here. So you want to pick a very big number. I'm going to choose positive now. Sorry about that. Positive infinity. This infinity symbol is in your calculator. So put 620 comma infinity comma the mean and the standard deviation. So again 500 and 100. That command should give you probability that the percentage of student is above 620 would be, what is it, 11.1151. Okay, verify that with your calculator. One thing about the table, so for the table of values, the Z table gives the area to the left. So when you look at the table, it doesn't give you the this right side. It'll give you to the left. So it always gives you the area to the left of whatever value you are interested in right here. Okay. Um, you could get this same value by following the z-score. So if you do the z-score, it'll be z is 620 minus the mean of 500 divided by 100. You get 1.2. On the table, you'll look on the Z table, you look for 1.2, but remember that it gives you the area to the left. You don't want the area to the left. So what you're going to do there is you're going to subtract 1 minus whatever the table gives you, which should be about 0.8849. If you subtract that, then you should get 0.1151, which is the same thing that the calculator gave us. Number 3, what percentage of the students score between 450 and 600? So you want the probability, the percentage of students that score between 450 and 600. So let's see, the calculator command will be norm CDF. The low band will, oh sorry, let me sketch the picture here. So 600 is right here, and 450, so that was 500, 400, 450 would be, let's see, 500, this is 400, so it'd be right here. So this is the area that this is the section that I'm interested in getting. Okay. All right, so norm CDF, it'll be 450, the low bound, and it goes all the way to 600. The mean is 500, and the standard deviation is 100. Put that in the calculator. You should get about 0.5328. So about 53 in here is roughly 53%. If you want to do it with the table, then we got to get the z-score for each one. So you got to get the z-score for 450 minus 500 over 100, and get the z-score for the other one, 600 minus 500 over 100. Do that calculation for each one. For this one, you get negative 0.5. This is 100. And this one is 1.0. Remember that the Z table gives you the area to the left. And one is right here. So the Z score is negative 0.5, and the area for that corresponding area is going to be 0.3085, and over here is going to be 0.8413. So I'm not interested in the whole thing. So what I gotta do is I gotta erase. I, I gotta subtract. So it's like if I was erasing, I was taking away this part here. So if I subtract them, 0.8413, which is the whole thing up to one z-score of 1, subtracted by 0.3085, that should be about 0.5328. So that's the same work as the calculator command. And finally, we have this idea of cut scores. So it is kind of the opposite of what we just did on the last example. On the last example, they gave us certain scores and we found the area, but now we're going backwards. We know the area now. Now we need the score or the value here. So it says we can use the Z table to determine cut scores for percentiles. So find the corresponding, let me type it in here. So you're going to find the corresponding area in this in the Z table. You're going to translate it into a z-score, and then you use the formula to find the cut score. So let's do a quick example for that. And you could follow these 3 steps, and also remember that we could use the calculator. The calculator is going to be inverse normal. So in the calculator, you could look for inverse norm. And in here, you would put the area. Let me do a different color here. You will need to put in 3 things: the area, the mean, and the standard deviation. So remember, this is the area to the left. Okay, so now, um, what scores make up, what score marks the top 10% of SAT test scores? So you see here from the picture, I don't know what the cut score is, but they're telling us that this is, that I want the 10%, top 10%. So that's 0.10. That means that down here to the left of it is 90%. Okay, so this is 90%. The mean is 500, so we want the 90th percentile. So you go to the table, and you look for the 90th percentile, and that should tell you the z-score. So method number 1, it says use the calculator. Inverse normal, you want 0.9, comma 500, comma 100, and you should get that the cut score is going to be 628.16. That's what the score would, that's the score in order to be in the top 10% of the SAT. And to show you a second method, to do it by hand instead of the calculator. So on the Z table, a you look for the closest value inside of here. You look inside for 0.9000. Not over here, not in the margins are the z-scores, so you don't want the z-scores. You want it inside of here. This table doesn't show it, but this one over here, this one does show it. So what you're going to see that the closest one is going to be the z-score of 1.28. So then you use your formula, you plug in 1.28 for the z-score, x you don't know, the mean is 500 and the standard deviation is 100. Work it out, do with a little bit of algebra there, and you get 628, which is the same as our calculator command.